Anyway, thanks for joining our community meeting this morning. We have sort of a light agenda, filling in for Matt, who's out today. But I think we want to start off and talk a little bit about the demo that we SwRI put on at Automate for sort of ROS Industrial, this scan and plan example workshop. Sort of talk about what we did in that project as an example of sort of a scan and plan application. Talk a little bit about like the architecture and how it works and how you might deploy it and what some of the cool tools are as a part of that. And then after that, I think we'll sort of open it up for sort of just general discussion for people to share things that they're working on and maybe other sort of relevant things. So feel free to jump in with questions or comments as we get started, and yeah, we'll go from there. So I'm gonna share my screen here. Let's see. Can you guys see my screen okay? Should be sharing a sort of architecture diagram.
Yeah, we
okay.
can see it.
Okay, perfect. Thanks. Yeah, so as a part of this demo that we did for Automate, basically we wanted to put together sort of a demo scan and plan application that we could sort of use as a demo, but then also as sort of like a template repository for just doing basic scan and plan. So this particular repository is public and open source. So it lives up here on the ROS Industrial Consortium GitHub page. It's called Scan and Plan Workshop. So you guys should be able to see this repository. So this is essentially what I want to talk a little bit about. We've done quite a bit of work through the ROS Industrial Consortium, sort of developing the tools for doing scan and plan type applications for doing like surface reconstruction and toolpath planning and motion planning. But we don't have too many, I guess, modern examples of how we're tying those different tools together into an application. And so that's sort of what this repository's purpose is, just to sort of unite those together in a sort of simple application. So if those of you who are familiar, we've done a couple of these applications in the past. Maybe the most familiar one is the Godel project. So that was part of a series of focused technical projects that we did with the consortium that was sort of focused around scan and plan as well, but that hasn't seen very much development in a number of years. And so this is sort of maybe a second rev at most of the content that was in Godel as well. But yeah, so sort of starting it off here, when we talk about scan and plan, right, we basically have a robot and we want to do some sort of task on something that the robot has never seen before. So generally the concept involves using a sensor to observe a part in the workspace of the robot, doing a surface reconstruction, and then using the resulting mesh to do toolpath planning for some sort of like surface processing task. So in our case, we do stuff like sanding or painting. In the case of the demo that we did at Automate, we were basically trying to like buff a surface or erase some stuff that was drawn on a surface. And I think there's probably a video here I can dig up and show after a while. But normally that's sort of yeah, the flow is do a surface reconstruction, generate toolpaths on the surface, and then send those toolpaths to a motion planner to figure out how the robot should move through those and then actually execute it. So generally our architecture of this repository looks something like this, where we've got some hardware, we've got a robot and some sort of sensor. So that sensor publishes out depth images and color images. And those are both used by sort of open 3D industrial reconstruction pipeline that we've talked a little bit about, that also exists on the ROS Industrial GitHub organization. Basically, it takes in images, depth images, color images, and the TF sort of location of the camera during a scan path, and then outputs a mesh that is the reconstruction of that surface. We have sort of like a GUI hub that is kind of the brains of the application. And so it communicates back and forth with this reconstruction node and to tell it, hey, I need you to start doing the reconstruction, and then, hey, I've finished moving, stop the reconstruction, and give me the mesh that was produced. And so that's sort of this flow of information here. And so then once we have the mesh, the GUI essentially sends that to another node that does toolpath planning using our Noter library. Also exists out on ROS Industrial Organization GitHub. But basically, we take that mesh, we sort of set up a toolpath planning pipeline about how we want to generate waypoints for our process on the surface. So in this case, doing sort of a raster type pattern on the surface for this like surface processing task. That node creates all these waypoints, sends them back to our application. Our application then forwards those to a motion planning server. And in this case, we're using the test-rack motion planning framework to do all of our motion planning. And so then we generate a trajectory to do a free space move from our kind of home position to the first waypoint, and then do sort of linear motion planning for our process, and then plan a free space move from the end of the process all the way back to the home state. And so our planning server handles that for us, sends that resulting joint trajectory back to the GUI. And then when triggered, the GUI can sort of forward that to our motion execution node. That's sort of like an interface that sits between the application and the actual hardware. So in this case, for our demo, we were using a MotoMan HC10 collaborative robot. So this execution node basically takes our joint trajectory that we want to execute, does a few things as far as like turning off and on IO and enabling the robot, and then calls the sort of follow joint trajectory action on the MotoMan driver to actually get it to move back and forth through our trajectory. So the kind of interesting thing about this whole repository is that this was all done in ROS-2, with the exception of the MotoMan driver for now. We essentially bridged that, and that was the only component that was running in ROS-1, but everything else that we developed as a part of this repository is in ROS-2. So there's some sort of interesting things that we had to do to port some of our tools to be compatible, and we can talk a little bit more about that kind of going forward. But anyway, so that's sort of how this whole thing was set up. I've got sort of a live demo here of the cell in simulation that might sort of help connect the dots a little bit about what exactly we're doing. So this is our setup. Let me know if you guys can't see the RViz panel. I think I shared my whole screen. So, oh, perfect. Cool. We got it. Yeah, so I'm running this in simulation here. I'm not actually connected to a real robot. So we'll first sort of adjust where my robot currently is, so it looks sort of realistic. Turn off TF because that's sort of annoying. But yeah, so this is what not only what the GUI looks like when you launch sort of the startup launch file. Basically, it's kind of a very simplified state machine where you can do a number of tasks, and as long as you do them in the correct order, then sort of the whole workflow progresses nicely. And if you try to do things out of order, it should hopefully tell you about it. But there's only a couple steps, right? We want to perform some sort of detailed scan to see what part might be sort of in front of the robot here. We want to generate a toolpath on that mesh. Once we have the toolpath, we'll generate the motion plan, preview it, and then execute the motion plan, and then we can kind of go back through the whole workflow as well. So in this case, if I generate a detailed scan, in simulation, it just fakes it. We put a sample mesh that we actually created using the industrial reconstruction library out here, but basically we kind of faked our way through a detailed scan and produced this sort of dome shape that we see here. And so the next step is, given this reconstruction, we want to be able to maybe select a region on the surface where we want to do some sort of processing. So for our demo, we basically like had this, it was actually like an upside down walk, and we coated it with some like dry erase board paint or something like that. And we actually were like drawing stuff on it with dry erase markers. And so when we did the reconstruction, those would actually, the images of the stuff that we drew would actually show up on the surface reconstruction. So we'd be able to see the stuff that we drew out on here. Yeah, so anyway, so nominally we want to select sort of around that thing and have the robot go down and buff out that drawing. So one of the cool things that we set up for this project was actually some new features to the Noter toolpath planning library. So basically we added a GUI package that sort of wraps sort of our revised interfaces to the different toolpath planners. So we're sort of in the process of doing a larger scale refactor of all the tools in that repository. So generally we have kind of a concept of a toolpath planning pipeline. And so the idea is that there's sort of 3 different steps in that pipeline. And first, the input to the toolpath planner is some sort of mesh, and the output is some toolpaths. But in between, our first step is maybe we want to apply some mesh modifiers to change the mesh that comes in for toolpath planning. So that can be things like doing smoothing of meshes, doing segmentation, doing region selection, stuff like that. That takes one mesh and potentially turns it into another mesh or multiple meshes. And given the output of that step, then we want to generate toolpaths for all those sort of sub meshes that were generated. And then after that, we have a step where we might want to modify the waypoints that were generated as a part of that toolpath. So we may want to do like orientation smoothing, or maybe we want to change the organization of the waypoints from being sort of a traditional raster to being more of a snake style pattern or something like that. So nominally we have those 3 steps in our pipeline, and this GUI is all sort of plugin based and allows you to see what available things you can choose from for each of those steps and configure sort of a custom pipeline for doing toolpath planning that you can modify on the fly and in a convenient way to be able to play with these different toolpath planning parameters. So anyway, before we go into this, this GUI here essentially is the node that's doing our toolpath planning. And it basically just has a GUI interface here. So we need to set up our toolpath planner before we try to generate toolpaths. So in our case, we only have one mesh modifier, and we want to be able to sort of select a region of interest on the mesh and have it extract that region of interest for toolpath planning. So I'm going to add that. And each of these things sort of has their own parameters as well that you can see. So this is sort of super user mode if you wanted to go in and play around with like all the parameters, but we could definitely set up different plugins that expose fewer parameters if that makes sense. So in our case here, we have only ported one of our toolpath planners to this new format. And so we're going to choose this plane slicer raster planner. And so it has the ability, I guess all raster planners have the ability to let you choose what direction that the rasters step along and what point on sort of your mesh does the first raster happen at. And so for this, we've got a couple different options. For the direction generator, we can say, hey, look at our mesh, calculate the longest principal axis and make those rasters step along the longest principal axis. And then we can also maybe specify a vector of the direction that we want to generate our waypoints. So we'll sort of play with both of those, but choose one of them for now. As far as the origin generator goes, you can specify, where a fixed origin is that you want to start at and step in the direction specified by the direction generator. SwRI just places it at the middle of the selected mesh, and then the axis line or origin generator, I believe, puts it at sort of the origin of the axis line bounding box. So in our case, I think this planner actually hasn't really fully conformed to our interface, so this selection doesn't matter currently, but we're sort of in the process of fixing this planner to obey these a little bit more. But anyway, these all sort of come with their own parameters as well, and you can expand and contract them. But then this exposes all the raster planning parameters as well, like the line spacing and point spacing. And so we'll mess around with these a little bit as well. And then finally, at the end, we've got a lot of different toolpath modifiers that we can apply. For this particular one, we wanted to change from being sort of a left to right, left to right, left to right raster organization to a left to right, right to left, left to right, right to left sort of snake style organization. So we'll add that modifier in. And then we also added some orientation smoothing as well. And so this particular one just looks at a window of points around every given point and averages the orientation of those points for the one in the middle to give a little bit smoother orientation in case that and for cases that the mesh itself wasn't completely smooth. So you can sort of modify how many points are in that window and things like that as well. But anyway, so we've sort of configured our toolpath planning node here. And so we're ready to go on to the next step, which is generating toolpaths. We have our scan. So if we generate a toolpath and we don't do any sort of region selection, we'll see that our toolpath gets generated over the entire surface. And I'll make these a little bit smaller. Sort of see, okay, well, maybe that's not exactly what we wanted to do. Maybe those points are a little bit too wide. So then we can sort of come back here and say, well, you know, I really think that these need to be an inch apart and that the points need to be maybe 15 millimeters apart. And we can just go back to our GUI here and regenerate the toolpath and get something that's sort of completely different. So that's sort of the cool aspect of this GUI is that we can go in and change all these different parameters and say, okay, well, I don't want to generate them, you know, where we step along the x-axis, but maybe I want to do it at like a 45-degree angle where I go step in the x and step in the y. So I can come back here and regenerate and have my toolpath sort of reflect those parameters on the fly. So yeah, so this is sort of cool, but maybe we don't want to do toolpath planning over the entirety of the surface. Like in our case, actually it's hard for the robot to get down towards this back end here. So we want to be able to select some region of interest on this particular mesh. So we built in this region of interest modifier, mesh modifier thing. So the way it works, we have this custom polygon selection tool. You can share, I don't think it exists on the ROS Industrial GitHub yet, but probably will be moved there shortly. But the idea here is that we can essentially draw some sort of region of interest, like a lasso style tool. And then this is sort of the region of interest that we want to generate toolpaths relative to. So then our particular node here, this ROI selection mesh modifier, sort of knows how to extract the region of interest that was drawn by this tool. And so if we go back and say generate toolpaths, now we can generate toolpaths that only exist inside of this particular region of interest, which is pretty neat. So I think this seems like a reasonable path. We'll see if we are able to do motion planning for it. So at this point, we have our toolpath, we have our detailed scan, we're ready to generate a motion plan. My computer's a little bit slow, so this step takes a little bit longer on my computer than it probably would on most other computers. So bear with for a few seconds. But I guess in the meantime, we can sort of talk about our toolpath planning pipeline. But you want to talk about that, Tyler?
What do you mean the toolpath?
Or sorry, the motion planning pipeline, not the toolpath planning.
It failed.
It failed, yeah.
Yeah, so I mean, basically here we're using tesseract for the motion planning. And so it's using a profile that allows it to take in rasters. I don't think we're doing global planning here, but it's basically we'll plan in parallel all of the individual rasters and then the connections between them with a task flow dependency graph. And it'll run Descartes first on the rasters and then go through TrajOpt on each of them and then try to connect the rasters with TrajOpt or to join interpolated first if it can, and then TrajOpt if it fails that, and then OMPL if it fails that, and all run in parallel at the same time. And so hopefully it should run a little bit faster than it otherwise could have. But we also, in this case with Descartes, are doing axial sampling because we had just basically a circular buffer, as Michael was saying, so it didn't matter orientation. So hopefully we get a pretty smooth trajectory that rotates as it moves across the surface. Is there anything else in particular you want me to talk about?
Yeah, no, I think that hits the high points. Yeah, so it's sort of a cool aspect of the motion planning capabilities of tesseract is sort of lets us try lots of different things and optimize, you know, our planning efforts, right? If we can do things joint interpolated and they're collision free, then maybe it doesn't actually make sense to push those through, you know, other planners, or, you know, maybe we do run it through Descartes and then try to smooth it with TrajOpt. And so there's a lot of cool option that we have, and maybe we should like make that its like an own discussion at some point.
Yeah.
Because there's a lot of content there that people might be interested in. But it looks like we were able to successfully plan. And so like Tyler was saying, we're doing axial sampling about the z-axis. So basically we have freedom to rotate the tool about the z-axis. And you can sort of see that as we move through here, that the tool orientation is changing as it goes through the rasters, even though the tool path doesn't really specify that. And so that's sort of the feature of the axial sampling in the planner, is it lets the robot choose a configuration that's maybe more natural or reachable for the robot, if that is the case for the tool. So at this point, we have a preview. We watched our trajectory. It didn't look like it's going to do anything crazy. And if we're hooked up to the real robot, we could hit this execute motion plan button and have it actually go through and execute this path. So, yeah, so that's sort of the demo in a nutshell. Got a few more things that we can sort of touch on, and then we can open it up to questions, and then open it up to sort of general discussion for other topics. But I did want to touch on how we sort of set this demo up and what it would take to deploy this demo on a different set of hardware. So I think there's a few changes that we want to make, but nominally the URDF and hardware specific things are confined to this S&P bring up ROS-I package and S&P support package. So our S&P support package is just sort of a traditional like ROS support package that has URDFs and meshes and launch files for like loading the robot description parameter with our URDF and things like that. So there's not really much special here other than, this is where we put together our Zacro for what the work cell looks like, and we have all of our sort of requisite meshes and things in here as well. So if you made your own work cell, then you would have to do something equivalent to this, making your own URDF and making sure that you can like load it to parameters for other nodes to extract the URDF. And then in the bring up ROS-I package, we basically just have some configuration files, which I think is just like an RViz file. And then basically just a single launch file that says, hey, we're gonna find our support package and launch a node that uses RViz and loads up the URDF to a parameter, and I think publishes that URDF out on a package, or sorry, on a topic. And then we launched the Open3D interface. So if we're simulating, then I think we have basically like I guess unless we're simulating, this is what we do when we launch the actual reconstruction pipeline, is the Open3D sort of interface, which I think this name has probably changed slightly. But anyway, we launched the Open3D industrial reconstruction node as well as the RealSense node. Otherwise, we have sort of a standalone executable that we made for sort of simulating the scanning that basically just loads a mesh from some predefined file. We have this TPP node that's doing the toolpath planning, the GUI that we talked about. Motion planning, motion execution, and then if we had a ROS-II robot driver, it wouldn't sort of exist here. But like I said, we were running that in ROS-I for this demo, so we didn't actually have anything that goes there. And then finally, the application GUI with some of the required parameters here. So nominally, I think in the near future, we're probably going to unite the S&P bring up ROS-II package with the S&P support and have, I think, 3 different like reference implementations. One that we did for ROSCON in 2021, this cell that I showed that we did for Automate last month. And then we're working on another one internally for sort of a demo cell that we have here at SwRI. And I think we're going to sort of make that a 3rd implementation package that's going to live out on this repository, just so we have some examples of how you use sort of all these same scan and plan application tools, but with various different hardware configurations and stuff. So be on the lookout for that. It's probably going to come, I think those 3 changes will probably be made maybe by the end of the summer, I believe. So still sort of working on that slowly. And we still have a couple of open pull requests as well from what we've done at Automate as well. So a lot of like the GUI and stuff is still an open pull request against this that we're hoping to have merged in probably in the next week or 2. But anyways, that's a lot of talking for me. Happy to answer any questions you guys might have about this. And if we don't have questions, then I'll sort of open up the floor for other general discussion. Feel free to jump in and maybe share some stuff that you're working on, or if you guys have sort of development questions, I'm happy to sort of like open up the floor to those and try to respond to them and just get some general discussion going. So any questions on this scan and plan workshop repository?
Nothing in chat.
Okay, cool. Well, if if you guys have any questions, feel free to poke around at this repository, open issues, open discussions. Definitely looking for people to sort of try it out and let us know, what we can do to improve it. And hopefully it's a good reference implementation for doing scan and plan and some Tesseract motion planning as well.
Maybe drop the link in chat.
Yeah, I'll put the link here in chat, and then yeah, I'll have that as well. Cool. Yeah, I guess with that, just sort of open it up to general discussion. If anybody has anything that they want to share about things that they're working on or interesting tools that they've come across in the last quarter, this is kind of free game for anybody to jump in. But. Oh yeah, I'll put Tyler mentioned here that I'll put a link to the industrial reconstruction repository as well. We sort of been using that in a fork for a while, and we finally sort of pushed it to its own repository on ROS Industrial. So I'll drop that in the chat.
Hi, this is John Watson.
Hey, John.
Hey, just want to mention that Tesseract is now available on the Python PyPy server, so that if you want to use it from Windows or Linux, you just can install using pip, and there are instructions in, I think it's actually discussion. I think I have to add them to the README, but it's pretty fast to install now. You don't have to worry about dependencies installation. So.
Cool. No, that's awesome. That's sort of like all the Python bindings for Tesseract as well, right?
Yeah,
It's
so the
not like
Python bindings and then all of the dependencies are included in the wheel. So you don't have to worry about installing anything else. It's all self-contained.
Wow, that's super cool. That's awesome. Is that do those Python bindings include the planning stuff as well, or is that just Python bindings for the core Tesseract stuff?
No, it's got everything. It's got this is a rough list of the packages included in it. I don't know if it's complete, but it has at a minimum it has the Python bindings, Tesseract planning, Tesseract, Descartes, Trajopt, OMPL, PCL, ASSIMP, and a couple other Descartes, and I think I'm missing a few packages. They're all included in the wheel, so you can just install it on a clean machine and it'll all run.
That's cool. I'll have to try that out. I feel like that's probably one of the biggest pain points that we have with Tesseract is that it's become a big project and it takes a long time to build and compile. And so then when you write like motion planning nodes, they also sort of take a long time to compile. And it'd be really cool, on our side if we could like be able to leverage and like kind of prototype out a motion planning node in Python and have it, be able to like tweak all the profile stuff and all that without having to build a bunch of code. So definitely going to check that out.
So I've also worked on conda packages. They've been really difficult to get to be stable though. But that would include the C++ interface too in the conda packages.
Right.
You don't have to worry about building there either. So I'll take a look at that later this year probably.
Yeah. Yeah, no, that's awesome.
The
other news is that Ripperger has been accepted into ROS packaging. So it's available in Noetic and binary. I haven't done it for Humble yet for binaries, but it's in the package manager now.
Oh, cool. That's awesome. Very neat. As far as the conda stuff goes, is most of the, I guess the rest of the ROS build farm is more or less available on conda, right? For ROS Noetic. Is that true?
Yeah. So I haven't tried it for a while, but I have Tesseract in its own channel right now. It's Tesseract Robotics channel. And there was some weird compatibility issue between Conda Forge, which we were using as a basis, and the RoboStack project. So I think that's resolved. I haven't tried it recently. But yeah, I think the Conda going forward may be the better way to distribute packages versus the build farm because they have a more rapid update and more consistent, packaging. So.
Yeah, and I think you can hold multiple versions out there as well, right? So you could download like one of many different versions of Tesseract as well, right? Not just the latest.
Yeah. And I think that the biggest advantage is that you can have your own channel, which is totally under your control, but still globally available. So basically you just have a flag in your install command, include this channel, and it will include the data from there. So you don't have to worry about going through a centralized packaging system if you have like your own project you're working on. And then the global one is Conda Forge, which is I think it's 14,000 packages. So I guess the eventual goal would be to migrate your stuff into there eventually, so you get onto their update system as well. Because they every few weeks they do a tick where they increase the version of the dependencies and they do a rebuild of everything to match. So you are better off being in their system, so you get that update, but it's not required.
Right. That makes sense. Yeah, I think I tried to do sort of a full install of ROS on Conda with Tesseract for one of the projects I was working on. It's probably 3 or 4 months ago. And I feel like I got 95% of the way there. And then there was just one or two things that were missing in that environment that prevented me from having my full project sort of build off Conda. So I'll have to revisit and see if that's possible, because it would be really useful for setting up a lot of different development environments. If you could just have your own Conda environment that has everything that you need for each one, then mix and match and try to build less things from source all the time.
The guys doing it very responsibly to the problem. So, if you add them on GitHub, they'll usually get back to you pretty fast.
Yeah. Okay. Yeah, I might have to ping them and see what it sort of what the process is for building stuff on Conda, because I would be interested in doing that for some of the other ROS industrial tools as well, like the Noter toolpath planning and some of these other things that we sort of constantly build from source. That'd be nice if we could get some sort of Debian or Conda builds of that going. So if that's not a huge effort, then that might be some good low-hanging fruit to make some of these repositories more accessible, so you don't have to build quite as much stuff from source and go through that whole thing if you can just apt install or conda install them.
So there's a repository organization on GitHub. It's Tesseract Robotics Packaging, dash between the words, and that has all the conda scripts for the Tesseract project if you want to have like a base to start from.
Okay. Yeah, I'll have to go. I'll check that out. Yeah, thanks for sharing that, John. All right. Well, if nobody else has anything to share, then I think we could probably call this meeting. But yeah, thanks again for joining. And yeah, if anybody else has stuff to share, feel free to jump in. If you guys want to hang out online a little bit longer, talk about some specific stuff, I'll wait for a couple more minutes. But anyway, yeah, thanks again for joining in.
I had a brief question real quick. This is Adam from Ohio State.
Hey, what's going on, Adam?
Doing well. So I was curious. So you mentioned when we did you showed the scan and plan demo, you did simulate the mesh. One of the things I'm starting to look at is just trying to move a lot of my simulation into Gazebo. Basically try to model some of the camera and stuff like that. And I guess I'm trying to look as actually bringing the robot into the space. And so I didn't know if you've done much of that before, or if you typically try to avoid that. I'm just looking for some broad guidance.
Yeah, we definitely do what you're talking about. And I think there are a couple different options. It sort of depends on, I guess, the level of fidelity and what you're trying to simulate. So typically we've been using, I guess one of our coworkers who no longer works here at one point made a package called GL DepthSim. I can drop it in the chat here, but basically it just uses OpenGL to simulate depth buffers and depth cameras, basically. So basically just provide it some representation of like meshes that are seeable, and then you just sort of dynamically change the position of the camera as you're recording, and it'll output a depth image or point cloud. And then basically we use that a lot of times as our simulator. That way we don't have to go into Gazebo and sort of develop, like, put together all that pipeline. So that was sort of our initial motivation, is like we thought about going to Gazebo or Ignition because they have all the cool plugins and stuff, but it just feels like a lot of overhead for simulating, like a point cloud that we don't really need to introduce or want to introduce like a ton of noise to. So it's been a really cool and pretty lightweight simulator tool for like depth cameras. But if you want something a little bit more complicated, and if you want like physics, then I think it starts making sense to be in an environment like Gazebo. But if you're just trying to simulate like a single depth camera, then Gazebo dust sort of feels like a little bit of overkill, especially when we're not using any of the physics or any of the other stuff, right?
So I can
Right.
also add that and say I have used Gazebo to like simulate the robot trajectories and depth cameras. So we could like simulate this. Well, generally I've done it for simulating a registration process rather than a full reconstruction like we have here in our demo. But yeah, I have it where I can dynamically spawn or load meshes, and then I had a Gazebo plug-in depth camera attached to a specific link, and I could run it and send the robot trajectories to execute in Gazebo, and it would take point clouds and have the live point cloud. I also actually did it with regular images, like 2D images, and I was simulated a full calibration process of a camera by loading in mesh object that had like a calibration board on it. Gazebo, you definitely can use that. It has some nice plugins that are convenient, but I think GLDevSim is also another valid option. So there's kind of multiple ways depending on how you want to go about it.
Gotcha. No, that makes good sense. One of the things I've got someone else in the lab that's trying to basically look at simulating the robot as well, as like you said there. And I know they end up going down the route of basically trying to put in their own PID controls for the individual motors and basically just load the robot description and do the controls themselves. And that seemed like, it seemed like a backwards method to me. I haven't dove into it a lot myself, but I kind of imagined we could leverage the existing like ROS Industrial Simulator, the Industrial Robot Simulator package. And this obviously be in ROS-I. But
I think, yeah, no, I definitely agree with you. I feel like doing PID control to simulate what a robot controller would do is probably a lot of like wasted effort.
Yeah.
Because I don't think you're going to be perfect on simulating it anyway, but I'm pretty sure Gazebo, at least in ROS-I, has like a, I don't know if it's a trajectory plugin necessarily, but I thought it had some sort of plugin where you can tell it like some joints are kinematic joints where you don't actually need to simulate physics or torque on them. You can just set their values directly. And then it's sort of like pretending that the robot controller has moved your robot to the joint state that you asked it to go to, and then you sort of just circumvent the whole controller aspect of it.
I think there's a follow joint trajectory plugin,
and there might be
you can use, and you can send it a joint trajectory action, a follow joint trajectory action, and it'll execute that joint trajectory while publishing on the topic. So it's basically like the industrial robot simulator.
Yeah.
Yeah, that would be a much easier route.
Yeah.
Okay. Yeah, I'll have to check that out. Thanks.
Yeah, I think if you Google around, I think you can find it pretty easily. I'm not sure what it's called exactly, but I think something like follow joint trajectory action plugin will probably lead you to the right spot.
Definitely. I was going to say, someone's had this, Elsa's definitely had this problem before. I just don't know what words to do yet. So
yeah, it's like half the battle sometimes, right?
Absolutely. So cool. No, this is really exciting. And I just got my mic working now. So I also wanted to say is I really like the scan and plan demo, and it's something I'm going to try to dig in the code and get running as a physical example on some of our own equipment.
Cool.
From
awesome.
university perspective, it's a really nice teaching tool for a lot of students to come in and kind of explain the process of, where all the data is flowing. So pipelines, et cetera. So.
Yeah, I think that's sort of half the reason that we wanted to do this as well. Is like we put on our own ROS-I trainings and stuff, and it's nice to have like an actual working example that we can use that does cool things, but it's sort of like simple enough that you can show somebody and say like, hey, this is like a pretty simple example of scan and plan. And especially if you like customizing it to work with your own hardware, if you wanted it to run almost exactly like it did here, is more or less just like you making your own support package and making sort of a custom launch file to bring everything up, right? So it's like you don't even have to touch the source code if you want it to run kind of exactly as it ran.
Right.
If you wanted to do something slightly different, then it's at least have like a bunch of the boilerplate sort of already there for you. You can go in and tweak how the different things work.
Yeah. No, it's really good for that.
If you guys find any improvements or issues, like don't hesitate to open issues and pull requests and stuff to try to make it better. So I think a lot of it is probably implicitly documented in our brains and may not make perfect sense to somebody else pulling it down. So if there's stuff like that, let us know and we can try to improve the documentation for sure.
Absolutely. Yeah. And I've got a lot of personal interest specifically in the concept of motion planning pipeline and how to handle all that. It's an area personally for me, I'm pursuing my master's and right now. And so that's kind of looking as a potential for a thesis topic and basically trying to explain and come up with recommendations for that process. So
Okay. Yeah.
so I'm
We'll
really
check that
curious
out.
to explore your stab at it. And
Yeah, it should be a pretty good example of maybe not the most complicated pipeline that we have, but definitely something it's not really trivial. So should be a good sort of entry example into what we can do with Tesseract and these motion planners.
yeah, awesome. All right. Well, thank you very much.